Hello and welcome to the Gestalt IT Rundown. Today is February 1st, 2023, and we hope that your sweet tooth is ready for a little bit of action because it is National Baked Alaska Day. It is also National Dark Chocolate Day. And if sugar and other things gives you a little bit of dopamine rush, we have another dopamine rush for you with a lot of great news stories in the lineup. Joining me is Mr. Stephen Foskett. Stephen, it's been a couple of weeks since we've done one of these together, but welcome back to the show.
It is great to be here, Mr. Tom. Thanks for hopping on here, and it's nice to see you.
It's nice to see you too. It's also nice to see that the news hasn't slowed down a little bit. You know, first month of the year, sometimes things can get a little bit interesting, but thankfully we've got some news stories that we definitely wanted to share with you. The first one of those is an acquisition. Dell has picked up an exciting new company to add to their growing cloud services offerings. You may have heard of Cloudify. There is an Israeli startup that focuses on cloud orchestration and automation. The company, which reportedly was competing with Dell's own Instradius solution, was quietly purchased for Dell for between $70 and $100 million. The acquisition was so hush-hush, in fact, that no one really knew about it until Dell had to publicly post some SEC paperwork related to stock acquisitions and transfers for some of those employees. But of course, as soon as it was announced, then Dell came out and said, yeah, we bought them. Stephen, what does this mean? Dell, are they really looking to kind of solidify some of their offerings around hybrid cloud?
Oh, absolutely. And I think that this is a good acquisition. As you mentioned, Cloudify was already competing with Dell, and I'm sure that Dell was watching that and saying, and thinking, hey, this is something that our customers, I mean, Dell's obviously a big supplier for really kind of Fortune 100 kind of companies globally, and those are the kind of companies that were using using Cloudify, adopting Cloudify, and using it as a way to manage a lot of the multi-cloud platforms that they had. I'm sure that Dell looked at that and said, that could be us instead of them managing that stuff. So why don't we buy it? The fact that they were able to acquire it for a reasonable amount of money is good. The fact that they acquired it quietly is a little bit puzzling, but maybe they didn't feel like it needed an announcement, or maybe they felt like it's just what happens, and it really kind of is what happens to a lot of these things, right? I mean, a company comes in. Dell sees their success, says, "Hey, this is somebody that could be a part of our company. We could have, they could have this layer. We could offer this to our customers. Let's do it." I really think that it fits really nicely within the Dell strategy. It's also good talent acquisition for them, and overall, it's probably not bad for their customers either, because essentially this is a platform that many of them were already adopting, and now it's part of Dell. So, overall, this is business, baby. This is business. Tom, Sysdig is a big name in the container security space, and part of the reason why is the way that they've embraced open source tools. One of those is called Falco, a container build and runtime monitor. The open source monitoring offering can feed Sysdig with information like IP addresses used by containers, connections, and other types of information. The data can be analyzed by Sysdig to find things that shouldn't be happening in a container farm, which is a good aspect of security in this containerized world. Tom, how important is it to find these problems quickly?
Given the fact that containers have a very ephemeral lifetime, you want to be able to detect these problems and then correct them either in the container itself or in the future very quickly. And if you don't think that that's important, all it takes is just a few minutes of being exposed somehow for someone to be able to, get in and do some nasty work, if you will. And Sysdig is a company that has been doing a really great job of kind of leveraging these things. But as you may know, if you've done any work in the security space, especially with these kind of detection platforms, whether it's a SIEM or a SOAR or XDR or anything else, you have to have data to be able to work off of, because you don't have an anomaly if you don't have a big enough data set to say that looks out of place. And so one of the things that Sysdig has always done a really great job of is taking those tools that they've built using open source methodology and providing them for people to be able to leverage. And that's what Falco is all about. You can run this as a container orchestration tool but it can feed that data back to the Sysdig platform and effectively say, hey, wait a minute, you're spawning a lot more containers than you're supposed to, or they're coming in with IP addresses that look out of the norm, or why are they suddenly making connections to servers outside of this organization? And that could be your hint that something doesn't look right. And I mean, we've told those stories for how many years now? It's like, why did this process suddenly start trying to contact a server in Eastern Europe? Well, I would want to know that right away, because if that's something that's been built into the container runtime that I didn't know about, then every time that container spawns off of a template or some kind of orchestration system, it's going to keep deploying and it's going to keep feeding that system. And I need to know that right away. So I'm really excited to see not only that Sysdig is leveraging tools like this, but they're making them available for us, because the more that people can use Falco in their own deployments, the more that they'll be able to kind of refine that process and help Sysdig get better at these things. So I'm kind of excited to see where they go with it, but also so that I can keep making jokes about Amadeus and other things. But I think that the future is pretty bright for them. All right, Stephen, Western Digital has a fun new drive on the market. The DC-HS760 data center drive is a traditional rotating disk that has some pretty impressive throughput numbers. I said traditional, but it's that way in all but one sense, because the HS760 is actually a dual actuator drive. That means that it has two read and write heads. In fact, the drive in the operating system shows up as two separate, distinct 10 terabyte hard drives that are both addressable by the system. That means that it has up to 582 megabits per second of I/O throughput, which is pretty impressive for a traditional rotating drive. It also is aimed at workloads that have a pretty even mix of read and write performance, as opposed to being overly balanced in one direction or the other, which might have you go to a different solution. Stephen, it's been a while since we've heard about innovation in the traditional rotating media department. What's the advantage of having two read and write heads?
Yeah, this concept of dual actuator drives is something that we've been looking at and expecting for quite a long time. Actually, back in at Storage Field Day 19, which was back in 2020, we actually went to Western Digital and had a presentation from them called "Continuing Hard Disk Drive Innovation from Western Digital." I'll put the link to that video in the show notes. That discussion actually presages all of what we're going to talk about here today. Essentially, there's some actually kind of cool innovation happening in hard disk drives. There's energy assisted media, which means basically heat or microwave assisted to make the spots on the drive smaller. There are various shingled and perpendicular and traditional media recording, which is a little bit more iffy, especially when you ask enthusiasts about shingled. There's also NAND flash being embedded on hard drives now to accelerate data access, which is very popular. And this drive includes that technology, by the way. And then there's zoned storage and multi-actuator drives. So essentially what this means is, as many of you know, a hard disk drive, if you open that thing up, there's multiple platters. Each platter has its own read-write head on its own little arm that goes back and forth. Back, about 5 years ago, the Western Digital and Seagate both said, what would be cool is if we could break that and have two sets of actuators that can move independently and access different things at different times, because that way you can increase the I/O capability of the drive without significantly hurting the overall throughput. Because otherwise, you essentially have all those heads moving together all the time across 8 or 9 platters. And that's what they've done here. So Seagate did it first a couple years back with their Exos 2X drives. Now we've got Western Digital shipping a drive that has this technology as well. It's very useful in data center and cloud environments, because one of the challenges there is that you want more IOPS, but yet you want the power and capacity efficiency and, frankly, cost efficiency of spinning media. And so by doing this, you can basically double the number of disk drives you effectively have in the system, which gives you more I/O, and yet at the same time not having to totally rearrange, re-engineer the system. That's one reason that this drive was launched quietly. It's basically being built and sold into hyperscalers because they're the ones who need this capability and they're the ones who can handle it. It's not something you're going to find on the shelves of your local Best Buy, probably ever. Maybe you can order yourself one at Newegg eventually, but essentially these drives are for special purpose applications that need disk drives that can handle more I/O, and the combination of NAND and multi-actuator gives them that capability. So as a storage nerd, as you can see, I'm nerding out. I'm excited by this. As a not storage nerd, you're probably saying, okay, cool. But it is kind of cool. It is kind of cool. It shows that there's some life in hard drives. One more thing I'll mention is that we have also had the hard disk drive companies announcing that they are indeed pushing forward with capacity, where we're going to have 30 terabyte and even 50 terabyte drives coming out soon, which is absolutely insane and awesome. And I can't wait to see those things get announced too. So stay tuned on the rundown. Tom, if it seems like the US has been banning Huawei from getting access to chips and tech from US sources for a long time, you're not crazy. Ever since 2019, the US has been trying to lock the Chinese networking giant out of the market. With every modification of the original order comes evasion, such as buying new unaffected suppliers or limping along with limited export licenses from Qualcomm and Intel. Well, Qualcomm even created a special version of their SoC to comply with the 5G export ban that was already in place. The US has decided that enough is enough, and they're signaling that they will outright ban export licenses for Huawei in the coming months. Tech companies are already grumbling about potential loss of such a huge customer. The ban would affect new licenses being granted and would begin to wind down existing licenses. Tom, is the US playing hardball here, or is this the last act in a long play?
So I don't know what they would be playing hardball about, because originally back in 2019, when the first limitations in this export license were put in place, the geopolitical climate kind of felt like they were trying not to completely put Huawei out of business. Again, that would be a really difficult thing to do, but they were trying to bring about some kind of change, and I don't know what they were expecting or what they were looking for. But when you limit the amount of things that you can export to these companies, and of course you probably remember from rundown stories 3-4 years ago, we were talking about the fact that the feds were banning people from implementing Huawei in certain situations where government network traffic would flow across them. They even offered to buy out those purchases and refund people money to put in literally anything else in. But it's always been this undercurrent of limiting some of the licenses, and then Huawei kind of going around it and trying to find different solutions. I mean, looking in the news stories that we linked, like Qualcomm was literally building an entirely different version of a specific SoC to remove 5G capabilities, just make it a 4G LTE SoC only, because you can't export 5G technologies to China. But what was the end goal? Like that's the thing I still can't wrap my head around. Was this to bring about some kind of a divestiture of their capabilities? That's going to be extremely difficult to do because Huawei is very integrated into the Chinese government. Was it to gain some kind of an oversight capability over those tools as they're being implemented? You're not going to be able to get away with that unless the Chinese government gets the same kind of oversight of US companies. So maybe the goal was to punish them or make them less desirable against US companies. Okay, that seems to be the case. Well, then if that's the case, then why are you outright banning them now? I think it's because they finally realized that they have to cut this off. There's no more beating around the bush. There's no more delicate negotiations. They're just done with the whole thing. So if the signals that are being sent out look accurate, then there will be no more new export licenses granted. Period. End of story. The existing licenses are already in place. Those will stay unless something major changes. Then they need to pull them. But when they expire, that will be the end of the game. So then Intel, Qualcomm, and anybody else who's been selling to Huawei lose a customer. Huawei is like, okay, fine. If you guys aren't going to sell me anything, I'll just take my toys and go home. Maybe what they're hoping is that by all of the other restrictions that they've been putting in place, like we talked about at the end of the year on the rundown, where they're going to prevent the lithography machines and all the other things from being imported into China, that they're hoping that companies that are like basically subsisting off of these semiconductor scraps that we're allowing them to have will come to the negotiating table for some end. I don't know what. But ultimately, what this means is that Huawei won't be selling in a year in the U.S. anytime soon, or outside of China, effectively. And the U.S. government is going to have to start answering some questions from their own internal companies about why this took so long and what the end result was going to be. And I don't think the government's going to answer that question. But I hope that that means that the U.S. doesn't start getting locked out of Chinese markets for the same reasons, with a similar shoulder-shrugging attitude of, well, you did it to us, so we're going to do it right back to you. That is the worst game of risk possible. Stephen, we have a story that we wanted to take a closer look at this week, and it involves Intel and some changes that they're making over there, because Pat Gelsinger isn't quite done cutting just yet. Two big changes that were announced. The first is that Intel is going to be shutting down their networking switch division. That includes Barefoot Networks. You may recall that they were purchased back in 2019 by Intel, and they had been trying to integrate that Tofino ASIC into a number of their offerings. The problem was that they were facing some pretty stiff competition from companies like Nvidia and Broadcom. And after that big loss that they suffered in Q4 of 2022, they took a look around and said, maybe this isn't where we need to be. They've already announced that they're going to be focusing more on DPUs, or IPUs as they call them, going forward. Also, there was an announcement that they're ending support for the Pathfinder for RISC-V program. That was a pretty big surprise to the people in the program, because the notification was just a little fold down at the top of the website. The program was really seen as kind of an olive branch being extended to the RISC-V community to kind of aid in development using industry standard practices. And Intel was hoping to kind of capitalize on some of those efforts, like, for example, being able to take the code that was developed and running it on things like FPGAs. The program was started back in August of 2022, so it's still relatively new, but it was supported by most of the big RISC-V companies. Now, Stephen, we've talked a lot about some of the moves that Intel is making and in some ways being forced to make. How do these stack up against what we've seen so far?
Yeah, I think I'm going to let you talk a little bit more about the network switching business. I do want to make sure that it's clear right off the bat that Intel is not ending its DPU product line by any means. In fact, it's still very much seems to be active in that space, and that's one of the things that is leveraging for the brand new Sapphire Rapids platform. Intel is also not ending its IDF initiative or even its participation with RISC-V community overall. What they're doing here is they're doing what Pat does now that Intel is facing some headwinds, which is cutting off big, expensive, or even small, but comparatively expensive things that aren't yielding results. The Pathfinder program, I'll dive into that. That was an interesting program because basically it was kind of Intel doing Intel old school, where the company sort of tosses some money here and there and tosses some support here and there to try to develop ecosystems that eventually will pay off for the company. By all accounts, Pathfinder was not very big and was not very expensive, but it was some money. And I imagine they didn't give it too much time, but I imagine that it probably was looked at and said, that's not really doing what it's supposed to do. Let's just move on. This doesn't mean that Intel is moving away from RISC-V, though. In fact, quite the opposite. We know for a fact that Intel is working with a number of RISC-V developers, IP developers, to produce these alternative chips in the Intel Foundry Services ecosystem, and that Intel is still actively supporting the development and production of those chips with IFS. That's been emphatically stated. As a reminder, RISC-V is an alternative instruction set. So just like you've got x86 and ARM, RISC-V is another one, except it's open source in that anyone can use it and expand upon it, and a bunch of companies are diving into it. In fact, a lot of companies are already adopting RISC-V chips as sort of peripheral chips and little chips here and there in different platforms. It's had some traction in storage, for example. If a brand new hard drive comes out, probably has some RISC-V chips. I've also heard a rumor that a big fruit company in Cupertino is using RISC-V in some areas as well. So we'll see. I guess we won't even know if they are, but we'll see how that goes. And I think that Intel sees this as a way to, a new market for their foundry services, and to help that get off the ground. Doesn't seem like they're moving away from that. Another aspect of this is FPGAs. So FPGAs are used to prototype a lot of new chips, including RISC-V chips, but also ASICs and so on. And those really only come from two companies. Xilinx, which is now part of AMD, and Intel's internal FPGA team, which was originally Altera. They are continuing that business as well, and they're supporting that. And that was connected with this Pathfinder program because a lot of the Pathfinder folks were rolling out sort of initial trials of their RISC-V architecture on an FPGA, which is incidentally is also what's going on over on the CXL side, where a lot of this stuff is being rolled out on FPGAs. That's continuing as well. So what's really stopped here is more of a B2B marketing program around RISC-V than anything. And so from that perspective, I'm really not worried. So again, to reiterate, IPUs, DPUs, XPUs seems fine, seems like part of Intel's strategy. RISC-V and Intel Foundry seems fine. FPGA seems fine. But network switches, does that seem fine to you, Tom?
No, that doesn't seem fine at all. And that's kind of weird because we knew that Intel had been taking the lead in networking. Like DPDK was the hot thing to talk about prior to the Tofino acquisition, the Barefoot acquisition of Tofino and other things. They were really, really hot on, talking about software and programmable networking and all these cool things. And then they bought Barefoot. And let's be fair, they bought Barefoot for the Tofino chip. And it was like exciting. I remember like hearing about it and going, oh, this is going to be so massive because, they get access to the P4 system and they're able to integrate all this stuff together. And this is super fast. And then nothing, like literally nothing. Like they talked about developing on it. The team from Barefoot was kind of integrated into Intel and serving in those positions, and quite literally nothing came of it. In the meantime, Broadcom and Nvidia and a bunch of other companies started ramping up and making faster and faster chips because at the time, Tofino was the game. I mean, it was a terabit per second throughput. And then what happened with it? I mean, I think it's hilarious that a company like Pensando managed to leverage P4 to kind of extend the instruction set to be able to make it operate a DPU, and they got bought. And so then what's Intel doing? Are they making reference architecture for switches? I don't know. Are they making data center switches? I don't know. Are they trying to integrate Tofino into the DPU? Ooh, now there's a good idea. What if they could find a way to kind of rebuild Tofino and make it an integrated part of a DPU, leveraging all those instruction sets and things like that? Boy, you'd think that was a great idea, wouldn't you? Why haven't they done anything with that? Like Nvidia has heavily leveraged ARM in the DPUs. We know that AMD is leveraging ARM and as well as FPGAs in their DPUs. Why hasn't Intel taken their flagship offering and integrated it in there? Maybe they will. Maybe this is just some window dressing, but we know for a fact that the last announced version of Tofino 3, which is the one that Intel had kind of effectively built, is the end of the road for that chipset. And it all comes back to, why does a big company buy a small company? Well, they want access to something that company has, but more importantly, they want to be able to refine the process for making it so that they can continue to enjoy higher performance at reduced costs. So you may buy the fastest chip on the market, but if it still costs you a fortune to make them, you're never going to be able to make them at scale. And I think that ultimately is what doomed Tofino. It was too much of it was too much of challenges to have it manufactured in the way that Intel wanted it to run. So if Intel can do something that approximates the performance of Tofino without all of the neediness that it has for specialized manufacturing, then I would assume that just like any other good company, they're gonna drop the hammer on it. The problem is that by no longer developing those chips, you've effectively doomed that entire market. So I guess that ultimately being fifth place in the data center switching supplier market probably not where Intel wanted to be. And they looked at the amount of money that they're pouring into this going, yeah, it's probably time for us to get rid of it. It just stinks because, they were right on the verge of kind of jumping into that new headspace of DPU, IPU, whatever you want to call it. And now they're kind of cutting their own legs out from underneath them because all of the value that they've generated in that market from all the development work they've done with Barefoot Networks is poofed.
Well, is it though? I mean, if they continue the DPUs, they continue working on P4. I'm sure that they're going to. I hope, please, Intel, keep the talented people on staff. Oh my gosh, you had some of the best people in the market there. If they continue that, I think that this could continue. I think this really comes down to a hard, cold calculation, cost-benefit calculation, which frankly is the same thing that happened with Optane. Intel looked at it and said, you know what? We're not getting the traction, the market traction. We're pouring a lot of money into this, and I don't see when it gets positive in terms of financials, and we just don't have the money to keep pouring into this, and so we're stopping it. I imagine as well, like Optane, that Intel is going to wind this down properly, but which Intel has absolutely done with Optane. In fact, they've got new products launching. They're taking care of customers, and I imagine they'll continue to do that as well. But they need to look at what sells. The only thing for me, the only flag that goes up here is in the graphics space. Because as we know, Intel's been working on GPUs that would be competitive with Nvidia and AMD for a long time. The initial products look fine, but there's been some talk about some reorgs there in terms of how Intel is working on that. And frankly, I see a very strong analogy between Tofino and the Intel graphics business, in that they're entering an established market with very strong competitors. They're putting together a product that is solid, but will they be able to get enough traction in the market where it counts in order to make the whole business make sense? And with Tofino, the answer was no. I don't know anything about this necessarily from internal, but from the outside looking in, if I were Pat, I would be looking at the graphics and GPU space and wondering whether that was worth investing in as well. So we'll see what happens there.
Well, one of the things that you can look forward to is some great events that we have coming up that you're definitely going to tune in for. The first of those is actually happening next week because I'm going to be in Amsterdam for Cisco Live EMEA. It's going to be happening February 7th and 8th. At least that's the Tech Field Day extra part that we're doing. We have a great lineup of presentations from our friends at Cisco covering mobility, security, and even some IoT stuff. So you're going to want to definitely tune in to watch that. And then afterwards, Stephen's got a couple of cool things coming up. Stephen?
Yep. Speaking of IoT and mobility, tune in for Edge Field Day, February 22nd and 23rd. We've got a great set of companies from across the space that are employing devices at the edge of the network in less hospitable environments than data center or cloud. Please do check out the Tech Field Day site for more on Edge Field Day. And also, we've got Tech Field Day 27 coming up in March 8th and 9th, which is going to have a day focused on CXL, which is a really exciting new architecture that we've been talking about on our Utilizing CXL podcast, as well as some networking companies. So check out the Tech Field Day website for more on the Tech Field Day 27 as well.
And if you want to check out the latest news on a weekly basis, you know where to do that. Right here on the Rundown. We will be publishing our episodes every Wednesday around 12:30 Eastern Time on our YouTube channel at youtube.com/GestaltIT video. We'll also be posting our show notes on gestaltit.com, as well as uploading podcast episodes. So if you prefer to consume your news in the audio format, then that is the way to do it. Just look for Gestalt IT Rundown in your favorite podcast application. And as always, if you have a news story that you think we would love to cover, make sure you tweet at Gestalt IT and use the hashtag Rundown, and we'll take a look at it. But we will be back next week with more great news. Until then, take care of yourselves, stay warm, enjoy February, and don't get bit by Groundhog Day. We'll see you soon.